So we are going to do 86. 86. And 86 says a cell whose internal resistance is 0.5 ohms delivers a current of 4 amps to an external resistor. The lost voltage is what? So what we're looking for is lost voltage. Lost voltage, Louis Vuitton. Lost voltage. The lost voltage is current multiplied by small r. Current here is what? Current here is 4. Small r is what? 0.5. 0.5. So that's what you're looking for. Lost current. Alright. 87. 87 says the resistance of a piece of wire of length 20 meters and cross-sectional area of 8 times 10 raised to the power. I don't really see that, but there's meter there. I'll just give the formula. I'm not seeing that figure there. Is what? The cell should read resistivity of wire to be 4 times 10 raised to the power minus 7 ohms per meter. So what are we doing here? We're looking for R. We're looking for R. The resistance of a wire was not given. So we're looking for R. We have the length, we have the cross-sectional area. That's we have area, that's A. So what are we going to do here? Normally, resistance in this case is equals to resistivity multiplied by the length over area. The resistivity is the 4 times 10 raised to the power minus 7. The length is 20 meters and your area is 8 times 10 meters. Or 8 times 10 raised to the power. I'm not seeing that very well, but that's just how to solve it in case you can denote what is on the 10. That's how to solve that. Right, let's go. So 88 says an ammeter of resistance 5 ohms has a full scale deflection when a current of 50 mA flows in it. The value of the resistor required to adapt to measure a current of 5A is what? So we're looking for a new resistance to pair with 5 amps. We're looking for a new resistance to pair with 5 amps. Alright. So when the current changes, what is the new resistance? So we can call that new resistance maybe Rn or something, or Rs. So that's the new resistance. So what are we going to look for first? We are going to first of all change this 50 mA to A. How do we do that? We divide by what? 1000. That is, so it will become what? 0.05. Okay, 0.05 amps. All right. The next thing we're going to do is we're going to look for our current. Normally, our current should be current is equals to the ammeter, the current of the ammeter plus the current of that's the new current, right? That's the new current, right? So let's put S there. So we have the current of the ammeter to be what? So now we're looking for this one, right? So if we take LA over that, it will now be LS is equals to I minus LA. LA is 0.05. Don't forget, LA is this one, 0.05. Why normal I now is 5. So this is 5 minus 0.05. Alright? You're supposed to get around 4.95. 4.95 amp. That is your LS, right? So we're just calling that guy LS. All right, so that's LS. Then the next thing we're going to do now, we're going to look for the resistance now. All right, we're going to look for the resistance now. And in looking for the resistance, we're going to say the resistance now is equal to what? Current of the ammeter, that's the 5, multiplied by the resistance of the same ammeter over the current we're looking for. That's this one. You are seeing it here. So that's this is LS. So this one over this one. Now IA is what? IA is 5, right? IA is 5. Arrow A is also 5. Oh, sorry. IA is not 5. IA is 0.05. It's a normal I that is 5, and we're not using that in this formula anymore. IA is 0.05. Arrow A is 5. Then your IS is 4.95. So that's what you are solving for. That's all what you're solving for. IA is 0.05. 0.05. That is IA. See it here. This one. That's this one. IA 0.05. Arrow A. Arrow A is 5. Then IS is 4.95. So that's what you are solving.